Hello, and welcome to episode 3 of From Paper to Clinic. I'm your host, Dr. Hamza Shah, and today we're joined by Dr. Michael Twa. Dr. Twa is a clinical scientist and dean of University of Houston College of Optometry. Dr. Twa practiced optometry for over 10 years in the Department of Ophthalmology at UC San Diego before pursuing his PhD in machine learning, data science, and biomedical image analysis. I've had the pleasure of knowing Dr. Twa for nearly 2 years now, and I can't think of a better guest to join me for a conversation on AI. Dr. Twa, thanks so much for joining in today.
Thanks. Pleasure to be here.
The article that we're using for our discussion today is called A Review of Recent Developments in Artificial Intelligence and Big Data Technologies for Ophthalmology Referrals and Clinical Practice by Alfredo Paredes and colleagues. Dr. Twa, the article talks about smart technologies. Can you share a little bit about these technologies and how the article suggests they can be implemented into patient care?
Yeah, I think probably the first comment I'd make is that already this article almost seems out of date when you look at the pace of change going on in the field. It's incredibly rapid. One of the things that they describe is the adoption of clinical decision making, or let's call it automated diagnosis, and looking at retinal imaging is one of the use cases they describe. And this was one of the problems that was tackled very early on in the use or application of AI towards clinical informatics. The problem was that there were many possible presentations of a fundus, and it looked incredibly different from person to person. And yet there were some common patterns that were detectable by clinician experts when trying to make decisions about whether or not there was diabetic retinopathy. So if what you need in a situation where you're trying to adopt AI is, especially among a population where images can be so varied, is lots of data. And fortunately, that existed. So one of the use cases that they paint is not only this adoption of AI for retinal image classification and diabetic retinopathy, which has been a fantastically successful venture, but then they also describe how this might further extend in newer applications for other diagnostic paradigms that we face in clinical practice. Another that they describe is the use of an application of chatbots. Perhaps helping patients navigate simple questions, repetitive sorts of encounters that they might have with either staff or care providers, post-operative care regimens, application of medications, all of those scenarios. Again, I would call them relatively formulaic. I would call them fairly routine in most cases, and probably a good use of a chatbot based off of large language models. A great way for AI to create a conversational interaction in an automated fashion and reduce the human workload and difficulty of fielding the same question day after day. So those are two use cases they describe. Is there anything in particular that you wanted to talk about with regard to how these would be implemented in eye care?
I think that was a good start. Now you mentioned fundus technology, fundus analysis technologies being used for diabetic retinopathy. Do you think it'll be more difficult to implement that for something like AMD or some of the more advanced eye care conditions other than just diabetic retinopathy? Is that what you're saying?
Well, I think the answer to that is yes. If they were more simple scenarios, they would have been tackled first, generally speaking. So when image analysis requires more nuanced interpretation, just as it may be a more nuanced and difficult task for a clinician, it can take AI a bit longer to work through the whole interpretation of the image. Let me back up just a little bit here. I think that the entire use of automated decision algorithms, let's call them, for making clinical decisions really comes down to the problem of sensitivity and specificity, right? And what you would like for these systems to be capable of doing is correctly classifying anything as abnormal, correctly identifying it as abnormal. Anything that's purely normal falls into the normal bucket. And then the problem that you have are the two types of errors that you can have: falsely labeling a normal case as
Mm,
abnormal for some reason, or falsely missing a case of abnormality and calling that a normal case. That's the sensitivity problem. Um, all of these systems are very good at detecting anomalies, but throwing
mm,
them in the correct bucket is where the problems begin.
mm,
Um, what's good about an computerized system is that it can be very consistent. It can apply a set of rules over and over again without getting tired, without introducing bias, um, and do a good job of following the rules that have been laid out for it. Now, the problems begin when the rules don't encompass what the designer had anticipated. Modern AI algorithms are better and better at learning those rules and adapting to new scenarios and improving with each iteration. So that's a good and promising thing. So subtle cases of macular degeneration could be distinguished from other chorioretinopathies.
mhm,
But you'll still have cases where you're going to make false positives and false
mm,
negative classification errors. So that sensitivity and specificity problem doesn't go away. Hopefully it gets smaller. Um,
mhm,
but whatever system that you're using is going to make those kinds of errors. I think where we have to, as clinicians, sort of think about this, or as researchers, allow for that in our thinking, is that if the computational task is just so large and so difficult that it's better handled by a computer,
mm,
um, it's okay to go down that path. You just have
mm,
to understand and be willing to accept that those kinds of errors of classification are going to occur. Pretty early on in my career, I always thought of these as decision support algorithms rather than
mm,
automated diagnosis and classification systems. I never
mm.
really wanted to rely on a machine learning algorithm to tell me what a diagnosis was. I was much more comfortable having an automated system flag an abnormality and require my human intervention and, um, you know, nuanced interpretation of the difficult cases. And that's, I guess philosophically where I've landed in how do we deal with this problem of diagnosis and classification from images.
Do you feel like that's where we're going, like not just eye care providers, but physicians in general, all type of healthcare providers? Is that where we're going, where we're going to use this technology for more like as a tool rather than having the tool or the technology di make the diagnosis for us? And with these more complex cases you're talking about where more data is required, do you think we'll get there soon, or is that 10 years down the line? What are your thoughts on that?
Oh gosh, there's a lot to unpack in what you just asked there.
I know. I gave you a mouthful.
Yeah, well, maybe maybe I'll start by just going back a little bit,
Okay.
to give some context of where we are. So Amazon launched an online bookstore in 1995, and then that rapidly grew into this massive global e-commerce company, and they did that by sort of, I would say, relentlessly focusing on understanding customer behaviors and meeting their expectations using technology. That was really what they were based on. A big part of that was creating sort of efficiency at scale, but at the same time maintaining a service that was individualized.
Mm,
That's a concept I think we're trying to achieve in healthcare, and
mhm,
we've even had a novel term for that in our field, which is precision healthcare,
mm,
which we strive for today. I think that many of the things that were in operation or in play in trying to develop a global e-commerce company are the same kinds of things that we're looking to do when we're thinking about how do we adopt AI in a healthcare environment. So there's a long way of saying that perhaps this early adaptation of AI in business really does have many of the same sorts of challenges and opportunities for us to adopt in a healthcare environment.
mm,
Our health system needs efficiency. It
mm,
needs that individualization in order to get our decision making right. So, will this tool flourish in healthcare? Well, it already has.
mm,
It has in the context of insurance company processing claims. It has in the context of the logistics of ordering and supplies of medical products. All of that is fabulously successful and has really helped us, I think, improve in our conduct of the business of healthcare. Where it's starting to make its inroads now, where people are less comfortable and less certain about what the future holds, is really in the adoption and application of this technology in individual patient care. And if your question is, does it have a place there? I think the answer is yes, it does. But I think it's still a long ways away from what really we're going to find useful. I mean, what we're doing today is probably very different from where we're going to be in 5 years. If you want me to try and predict where that goes.
I guess maybe if you gave a quick snippet in your opinion, where are we heading in 5 years? That would be, I think, valuable.
So, let me go back to the paper first. So they gave a lot of really nice looks into where was AI 2-3 years ago, and even at that point in time, I think I would say that agentic AI really wasn't a significant part of the conversation back then. Large language models really were a new use case of how artificial intelligence now could be applied to language. That is when people really had their minds blown around the possibilities of how we might use this technology. Mind you, we were already using it in many ways in the business world and analysis, but the ability to have a natural language conversation with a chatbot was an entirely new thing. To think that we could talk to a machine and that it could talk to us and give thoughtful and reasonable answers was a massive explosion of possibilities. I think if we look down the road 5 years, agentic AI provides that same thing. And I suppose to explain a little bit for our audience what that means, agentic AI is really about a tool that's trying to solve complex problems using tools, usually software. And by using those tools, it's given the instruction to go and solve a relatively complex problem with limited human intervention. So agentic AI, you can think of as your concierge to help navigate through a complex system and achieve a task that's optimal for you. If agentic AI works, you can imagine in a healthcare scenario, what these agents might do is schedule a patient's examination, post-care clinical laboratory tests, accumulate that information, share that back out with primary or specialty providers, navigate and manage a healthcare sort of referral pipeline. It's really something that can do abstract tasks that are optimal for you. Now, you can also imagine scenarios whereby we're performing not only analysis on data sets to understand how to improve the quality of care and the value of the care and the access of the care, but an agent can help streamline and navigate a complex system for us or with us. This has really been fun to watch its evolution. Anthropic, which has the Claude chatbot. One of the early tests of Claude was that the company gave it a responsibility for managing a store, and it had a set of humans overseeing it, another layer, if you will, just for safety concerns. They didn't want Claude ordering hundreds of millions of Tim Tam biscuits from Australia and going broke in the process of doing that. What they found was that Claude was pretty good, but it wasn't able to stay out of debt on its first tries. Once they solved some of the financial logistics, it had a hard time predicting the whims of its customers. So human behavior is still a complex thing, and agents that are trying to predict human behavior have a really tricky task ahead of them. But again, this is sort of an early foray into agentic AI, which these complex algorithms found rather difficult to achieve success in that realm. In a few years, they're going to be far better than they are today. And I think that we'll see that they become really useful tools, but right now they're clumsy toddlers,
Mm,
walking around in the grocery store picking up the sugared cereals first. So
hmm. Well, from what you just said, the article mentions a tool called Dora, an AI-driven chat box bot that's being used in UK to conduct follow-up calls after cataract surgery.
yeah.
That's freeing patients from follow-up appointments, freeing the doctor's space as well. What are your thoughts on that? I know it sounds like a past generation AI bot compared to some of the things you just mentioned, but what are your thoughts anyways?
No, I think that's a really useful tool. I think that's exactly what a chat bot can be useful for. This does come back to the sensitivity specificity question, though.
Hmm.
Imagine that you've got Dora who's giving you advice about your post-operative medications from cataract surgery, but you're not the typical patient. A chat bot may not know quite what to do with that additional information, even if they're
Hmm.
informed about it. They may not know enough about how these multiple comorbidities can be complex factors that require more nuanced decision making. And so, while the system like this may be pretty good at providing useful information in a normal routine scenario, I think that the hazard in a system like this is that it can quickly get out of bounds, and you've got to develop some guardrails that will ensure that whatever advice is given by this chatbot
Hmm.
can escalate appropriately to somebody who will have the ability to intervene and make sure that you don't wind up missing something important.
Absolutely. And then, that ties who takes liability in those cases? Is it going to
Yeah,
be the chatbot or is it going to be the doctor? And I think
yeah.
that's something we're in the process of figuring out. I don't think we've figured that out yet, that who is liable at the end. Would you agree?
Boy, that's a great question, and I don't necessarily want to try and infer the right answer in a legal space. I just don't have the
Hmm.
expertise to do that. But
Hmm.
really, again, I think it comes down to this tricky decision about escalation. There are always going to be unclear scenarios, and as I say, multiple factors in the patient care.
Hmm. Hmm.
It's going to, again, we will have errors, just as with humans or with chatbots. The question
Hmm.
is, how can we best avoid them, and how can we appropriately escalate those things? I don't think that perhaps it widens the liability to think
Hmm.
about an automated algorithm. I think the insensitivity of humans interacting with machines
Hmm.
probably creates an inclination for humans to want to look negatively towards chatbots as a machine making poor choices. But in reality, the fallibilities, I think, of humans that either program them or answer the
Hmm.
questions directly is always a concern.
Moving on a little bit away from the article, I know you're working on a really interesting project that leverages AI to analyze EHR data for research purposes. Do you mind sharing a little bit about that and what you're hoping to accomplish?
Yeah, thanks for asking. I think that's an exciting area for us right now.
Yeah.
So,
Hmm.
um, most of my career as a clinician, as a scientist, as a journal editor has been about encouraging wider adoption of those principles and practices of evidence-based care.
Hmm.
It also requires a thoughtful analysis of your own care outcomes. That's really what I'm doing, and that is trying to close the loop on understanding our care outcomes and making those things available and more accessible to our clinicians. I'm developing this AI integrated system that can help us analyze and report on those organization wide care outcomes. And hopefully, this will enable our providers just to query decades of clinical data with natural language queries. So, if we would like to know how many individuals within our diabetic patient database go on to progress towards moderate to severe retinopathy, and what are the not only the health data that we have that can indicate why that may have occurred, but more importantly, I think where the answers lie are going to be in some of the non-medical drivers of health outcomes, the social, behavioral, nutritional,
Hmm.
environmental exposures. If we can begin to incorporate not only our electronic health record data, but other adjunctive bits of data that we learn about our patients along the way.
I'm really excited to see that in action. That's going to be great. That's going to be fantastic. To end on, what would be your message to providers, to clinicians who don't have a background in machine learning, who are hesitant in welcoming AI into their clinical practice?
Yeah. Really, we're not looking at something that's new here. I think that realizing that this technology is not new is a really important fact. The use of AI for language and communication has gotten a lot of visible attention, but in reality,
Hmm.
AI has been around us for a long time and it's been
Hmm.
evolving for more than 40 years. I think my message would be to encourage literacy in AI, even if you're not actively using it in practice. Use it in your personal life. Try to figure out what these tools are all about, where they are in their development, and this technology is going to continue to change our environment, much
Hmm.
like, broadly, much like how computers have changed our lives.
Hmm.
In that sense, it's not really good or bad. It's just a tool. So learn what you can about it. Learn how it may be appropriately applied towards the things that you're trying to do to better patients' lives through improved care or whatnot. And then make sure that you're educated enough to know what are the potential hazards and problems associated with this as well, so that you become a responsible user and promoter. You know, adopt it or not, it will be in the environment. It will be
Hmm.
influencing the direction of how we go forward. Better to know something about it.
Some of the conversation I've been having them with younger colleagues, older colleagues, and it feels like, there is a slight fear around this technology, or that, hey, it's going to take over some of our responsibilities, take over our jobs,
Yeah.
whatever it may be. And when I talk to some of the older colleagues who've been in eye care for much longer than I have, they tell me this fear has been around for a very long time. It was there when OCT came out, when fundus photography came out, when EHR came out, when computers came out. So like it's
Yeah.
nothing new. And in their opinion is it's just an evolution similar to how we've evolved, these past, 50 years, how optometry has evolved, the past 100 years. And either, we take that seat on the table and help shape how it's going to evolve our career, or we let someone else do that. I think that then it becomes dangerous. So I know I agree with you. I think we need to understand it. I think we need to welcome it as a resource that can potentially help us in patient care, but not just, kind of shy away from it, because I think that's when things can get dangerous.
Yeah, no, you're right. The alarm bells have been sounded many times in my career. I remember, I'm young enough to remember the
Oh, right.
excimer laser coming on board, and that was going to wipe out the need for glasses or contact lenses. Well,
Right.
that hasn't happened.
Yeah.
Yeah, so it's real. It'll have an effect, and you can either embrace that technology. You don't even have to be an early adopter, but sit on the sidelines and learn about it and be informed. It'll make you better prepared to deal with how it's going to shape the landscape around you. So I think that's good. A 2016 National Academies report that said that really eye care and population and public health around eye care could be better improved if
Mm,
eye care were more directly integrated with the rest of healthcare. I think AI has the potential to facilitate some of that.
mm,
It'll take work. It'll take intentional work to achieve that.
mm,
But we will already have more information on the value and the benefits of our own individual behaviors and practices and how those benefit patients. I think that's a good thing. Let me just finish with one comment. I
mm,
mean, healthcare's got two parts to it, right?
mm,
Health, and that's sort of the science and the understanding of the biology of that system. And it's also the care component. I think for those who may be worried that AI is going to somehow replace that, I'm not too concerned. I think at the end of the day, people very much still would love to have a human involved that cares and has that compassionate component of what we do. But if they have this powerful tool to help them do it better, that's not a bad thing in my mind.
I think that's a perfect point to end on, and I couldn't agree with that more. I think that human component is always going to be there. It has to be there. And a chatbot can help diagnose, help treat, help evolve our process. But me having a conversation with you, or a patient having a conversation with me, it goes beyond just diagnosing, treating. It's the compassion. It's about asking about their kids. I mean, it's the reason why I go to the same barber for the past 10 years, or whenever I go to Chicago, I go to that same barber. It's the conversations. But
Yeah.
thanks so much.
Thank you, Hamza.
Well, this wraps up episode 3 of From Paper to Clinic. Thank you, Dr. Twa, for joining us and sharing such great thoughts. To our viewers, I hope today's discussion encourages you to welcome AI as a tool to help enhance patient care now and in the future. Episode 4 will air first week of June, featuring Dr. Caleb Babbitt, and we will be talking about ocular surface disease. Thank you for listening, and I hope you'll join next time.